Okay, let's continue where we left off. Schemas and types. The GraphQL system describes what data can be queried from the API. The GraphQL describes what data can be queried from the API. The collection of these capabilities referred to as the services schema, and clients can use that schema to send queries to the API that return the predictable results. On this page, we'll explore GraphQL's 6 kinds of named type definitions as well as other features of the type system to learn how they are used to describe your data and the relation between them. Since GraphQL is used with any backend framework or programming language, we'll avoid implementation specific details and talk only about the concepts. Type system. If you have seen a GraphQL query before, you know that the GraphQL query language is basically selecting fields on object. For example, in the query following query, as you can see here, you have seen that, right? So here the name, you have the name here that appears in, you have the news hero or the stuff. We start with a special root object. We start with a special root object, which is this, and we have the hero field on that, which is here. For the object returned by hero, we select the name and appears in fields. Because the shape of a GraphQL query closely matches the result, we can predict what the query returned without knowing that much about the server. But it's useful to have an exact description of the data we can request. For example, what fields we can select, what kind of objects might return, what they return, what fields available on those subscriptions. But here's the problem. So when I think about this, should I know every fields and properties that you are dealing with? But in my experience, yes, you need to know if you have, if you are available, like if you are aware of what you are dealing with, because every program is basically data. So if you have a clear understanding of the data, hey, for this request I just need this kind of data that I should display. But when it comes to the rest, of course, you have every data. In future, you might just use it. But when it comes to GraphQL, it's better if you know only the data that you actually need, so that you can avoid redundancies or requesting data that you actually don't need to. So that is a good practice if you know everything that you want to do, you want to have. That's where the schema comes in. Every GraphQL service defines a set of types that completely describe the set of possible data that we can query on that service. Then when requests come in, they are validated and executed against that schema. Type language. GraphQL services can be written in any language, and there are many different approaches you can take when defining the types in a schema. Some libraries have you construct the schema types, fields, and resolve a function together using some programming language that can be used to write GraphQL implementation. Some libraries allow you to define types and fields more ergonomically using what's commonly called the schema definition language (SDL), and then writes the resolver functions for corresponding fields separately. Some libraries allow you to write and annotate the resolver functions and then infer the schema from that. Some libraries may even infer both the types and resolver functions for you based on some underlying data sources. Since we can't rely on a specific programming language to discuss GraphQL schemas in this guide, we'll use STL because it's similar to the query language, and we have seen so far. Allow us to talk about the GraphQL schema in a language agnostic way. Object types and fields. The most basic components of a GraphQL schema are object types, which just represent a kind of objects you can fetch from your service. And what fields it has. In STL, we represent it like this: type, character, name. You call it a name, you give it a name, like what a character. Let's say a villainy character called Voldemort. Of course, you can't name him. You know, he who must not be named appears in which episodes? Well, at the end of the movie, in the first season. Yeah, first season, not the first season, for the first Yeah, the first movie part. Yeah. The language is readable, but let's go over it so that we can have a shared vocabulary. Character is a graphical object type, meaning it's a type with some fields. What's the object? It's a basically a type with the fields. Most of the types in your schema will be object types. Most of the types in your schema will be object types. Name and appears are in fields on the character type. That means that name and appears in are only fields that can appear in any part of your graphical query that operates in the character type. String is one of the built-in scalar types. I don't know what's the scalar types, but let me just quickly have that. If it is coming afterwards, it's fine. Yeah, it's coming afterwards. So we don't have to worry about it. We'll go through this. These are the types that resolve to a single scalar value and can't have sub-selections in the code. I hate it when you could have explained some, you know, some definitions earlier, and you are just saying, hey, by the way, it's a scalar type. String is one of the built-in scalar types, and you don't know what a scalar type is, and then you go for the scalar types, and then you are in a rabbit hole. I never liked it, but just go with this. These are types that resolve into a single scalar value and can't have subselections in the query. We'll go over the scalar types more later. String means that field is non-null type, meaning the GraphQL service promise to give you a value that whenever you query this field. In STL, we represent those with an exclamation mark. Episode represents a list of type objects. When a list of non-null, you can always expect an array with a 0 or more items when you query a appears in field. In this case, since episode is also a non-null within the list, you can always expect every item in the array to be an episode object. Now you know what a GraphQL object type looks like and how to read the basics of SDL. I think this is basic stuffs you just can understand, I guess. Arguments. Every field on a GraphQL object type can have 0 or more arguments. For example, the length of the field below. As you can see, length have a unit, which is also a length unit. Then you have, for example, they have given a default value, which is meter, and length is a float. So a GraphQL object type can have 0 or more arguments. For example, if it is an object type, it can have, of course, if it is an object, of course, it can have an argument. All arguments are named. Unlike languages such as JavaScript, Python, where functions take a list of ordered arguments, all arguments in GraphQL are passed by name specifically. In this case, the length field has one defined argument called unit. Arguments can be either required or optional. When an argument is optional, we can define a default value. If the unit argument is not passed, then it will be set to meter by default. The query, mutation, and subscription types. Every GraphQL must be a support query operations. The entry point for this root operation is a regular object type called query by default. So if you see a query that looks like this, which is droid, you are requesting a droid and it has 2000, just imagine a droid with an ID of 2000 and it has a name. What do you call it? Droid is R4 T4, T4 R4, I guess R4 24, anything. And then you have, of course, you have C3P0, 3P0, droid name. That means the GraphQL service need to have a query type with a droid field. That means the GraphQL service needs to have a query type with a droid field. Schemas may also support mutation and subscription operations by adding additional function mutation, subscriptions, and then defining fields on the corresponding root operation types. It's important to remember that other than the special status of being entry points into the schema, the query, mutation, and subscription types are the same as any other GraphQL object type, and their field works exactly the same way. Schemas may also support mutation. Okay, let me just go through this quickly again. Schemas may also support mutation and subscription operations, and by adding additional, so mutation is probably like update, delete, and subscription, I think it's probably for the real time streaming, something like that, where you like background task, something that is real time. I guess like public subscription, that's what they mean. Operations by adding additional mutation and subscription types and then defining fields on the corresponding root operation types. It's important to remember that other than the special status of being entry points into the schema, the query, mutation, and subscription types are the same as any of the other GraphQL object types, and their fields work exactly the same way. You can name your root operations differently too if you choose to do so. Then you will need to inform GraphQL of the new names using the schema operation, schema keyword. Schema, query, my query type, mutation, my mutation type, subscription, my subscription type, scalar types. A GraphQL object, so now we are back to the scalar types. A GraphQL object types that has a name and fields, but at some point, those fields must resolve to some concrete data. That's where the scalar types comes in. They again have a reference to it. What? They are the official representation. Okay, the scalar types represent primitive leaf values in GraphQL type system. GraphQL responses take the form of hierarchical tree. The leaves of this tree are typically GraphQL scalar types, but also may be enum types or null values. GraphQL provides a number of built-in scalars which are fully defined in the sections below. However, type systems may also add additional custom scalars to introduce additional semantic meanings. In the following query, the name and appears in fields will also resolve to scalar types. Data hero art. So this is basically what I was actually trying to remember. R2D2. Everybody remembers that Star Wars. We know this because those fields don't have any subfields. They are the leaves of the query. GraphQL comes with a set of default scalar types out of the box. Int, assigned 32-bit integer, assigned double precision floating value, a UTF character sequence, a unique identifier often used to refetch. Okay, yes. GraphQL comes with a set of default scalar types out of the box. So you have int, signed 32-bit integer, and then you have float, assigned double precision. I don't know what's assigned means. I really don't know. Assigned double precision. Okay, I know what's a int. I know what's a float. I know what's a string. I know what's a bool. I don't know what's a ID doing here. So it's basically a unique identifier often used to refetch an object O as a key. So this is basically what's doing under the hood. You have an ID. So this is but what actually often used to refetch an object as O as the key for a cache. The ID type is serialized in the same way as a string. However, defining it as an ID signifies that it is not intended to be a human readable. Okay, yeah. In most GraphQL service implementations, there is also a way to specify some custom scalar types. For example, we could define a date type, scale a date. Then it's up to our implementation to define how the type should be serialized, deserialized, and validated. For example, you could specify the date type should always be serialized into an integer timestamp, and your client should know to expect that format for any date fields. So you have to basically come up with the date. That's what they're basically meaning, because they don't have a date type. So you have to come up with it. Enum types, also known as enumeration types, are special kind of scalar that is restricted to a particular set of allowed values. This allows you to validate any arguments of this type are one of the allowed values, communicate through the type system that a field will always be one of the finite set of values. Here's what an enum type definitions looks like. Enum episode, and you have all the episodes: New Hope, Empire, Jedi. Cool. This means that wherever we use type episode in our schema, we expect it to be exactly one of the New Hope, Empire, or Jedi. GraphQL service implementation in various languages will have a specific language way of dealing with enum types. In language that support enums as a first-class citizens, the implementation might take advantage of that. In a language like JavaScript with no enum support, These values might be internally mapped to a set of integers. However, these details don't leak out to the client, which can operate entirely in terms of the string names of the enum types. Types modifiers. Types are assumed to be nullable. Types are assumed to be nullable or singular value by default in GraphQL. However, when you use these named types in a schema or in query variable, you can apply additional type modifiers that will affect the meaning of those values. As we saw with the object type example above, GraphQL supports two type modifiers, the list non-null types, and they can be used individually or in combination with each other, non-null. Let's look at an example. Type character name string. This is basically, I think, non-null. Here we are using a string type and marking it as a non-type type by adding an exclamation mark after the type name. This means that our server always expects to return a null value for this field, and if the resolver produces a null value, then that will trigger GraphQL execution error, letting the client know that something has gone wrong. So if the character doesn't have a name, of course you can't find that character. As we saw in the example above, the non-type null modifier can also be when defining arguments for a field, which will cause the GraphQL server to return a validation error if a null value is passed as the argument. I think this is huge. Yeah, we have a long way to go here, so I think I will continue from the next video.